So let's talk about the industry problem, right? So we're talking about vulnerability management and how it's evolving in ProGet 26. So we're going to start with the core problem, which is that modern software relies heavily on open source. In most organizations, around 77 to 99% of the code base comes from third-party packages, according to OpenText State of Application 2025. Now, as that grows, naturally, so does the volume of vulnerability alerts that teams are dealing with. Now, most of these are prioritized using CVSS score. So when something gets labeled as critical, the instinct is usually to act on it right away. But here's the part that often gets missed, right? Now, a vulnerability can be labeled critical, but still not actually be exploitable in your system. So, for example, the code path might exist, but your application never actually executes it, or the vulnerability requires a specific type of input that your application doesn't even accept, or it depends on conditions like external exposure or certain configurations that just aren't present in your environment. So the vulnerability is real, but the conditions needed to actually exploit that vulnerability aren't. And that's really the key issue we're out to solve and discuss today. So CVSS scores reflect the vulnerability in the worst case scenario. It's not telling you whether something represents real world risk in your application. So, what we often see happening is these vulnerabilities still show up as high or critical, even when they don't really apply in practice. And that's where the challenge starts. So, we hear teams being asked to act on vulnerability data without really knowing what matters to them or not. And naturally, if you're spending time on remediating vulnerabilities or dealing with vulnerabilities that don't actually affect your environment or could not be exploited in your environment, that leads to wasted effort, unnecessary upgrades, and ultimately, if you're spending time on that and you're not spending time on building and releasing your apps, you're going to have delayed delivery of your proprietary applications. So, when teams are dealing with a high volume of alerts and not a lot of context, we often see the default response shift towards immediate remediation. So, that's the current approach most organizations take, right? So, anything that is labeled high or critical gets patched right away, often outside the normal release cycle. And on the surface, that makes sense, right? If something is critical, you would want to fix it quickly. But in practice, this is where the approach can start to break down. So, first, upgrades introduce unintended changes, right? So you're pulling in a new version of a dependency, and that can affect things like how it saves data, retries failed actions, or handles information. And those kind of issues don't always show up right away in testing. So what happens is you fix one problem, but you end up creating another. Now, another challenge is that simply it doesn't really scale. So a large percentage of vulnerabilities are labeled high or critical. So you end up with this constant stream of what appears to be urgent work, or it's urgent work by virtue of, company policies, right? So teams often report getting overwhelmed, and in a lot of cases, they start missing deadlines for fixing issues. So just to give you some context, Sneak's State of Open Source report states that despite about 74% of companies setting a 1 week or less deadline for fixing high severity issues, over half, or around 52%, still miss those targets at least some of the time. And it's not because teams are ignoring issues, it's because there are just too many vulnerabilities coming in at that level of urgency to realistically keep up. So, third, everything gets treated the same. So, a critical vulnerability in an externally exposed service is handled the same way as a critical vulnerability in an internal tool, even if only one of those is actually exploitable. So there's no real context. It's all just appears to be severe. And that means that you're reacting quickly, but you're not always reacting accurately to the risk. So another current approach we called controlled remediation, where instead of reacting immediately to every alert, we often see teams put a process around it. That usually means things like staging environments, validation cycles, approvals, and rolling fixes into planned releases. And the goal here is to be more deliberate, right? You want to reduce the risk of regressions and keep everything within your normal delivery workflow. But this approach comes with its own set of challenging. First, it can slow things down. Every vulnerability goes through testing and coordination, whether it's actually exploitable or not. Second, it takes a lot more effort, right? You're pulling in developers, QA, sometimes multiple teams, even for issues that may not pose a real risk to your system. Third, it often ends up being universally applied, right? So even vulnerabilities that aren't exploitable still go through the same process. They still get investigated, they still get tested, and they still get scheduled. So you're being more careful, but you're still spending time where it may actually not be needed. And that's the trade off. You reduce the risk of regressions, but you lose speed and efficiency. And just like the first approach, the immediate approach that I mentioned, you're still missing that key piece of context. So when you step back and you look at both of these approaches, they're really trying to solve the same problem, but they're doing it with the same limitation, right? Which is to say, they are relying on severity alone. And the issue is severity scores like CVSS don't actually answer the questions teams need in order to make good decisions. They don't tell you whether the vulnerable code is even being used. They don't tell you whether your application is exposed in a way that makes exploitation possible. Or finally, whether the conditions required to trigger the vulnerability are even present. And just as importantly, they don't tell you anything about the risk of upgrading the dependency itself. So you're really missing both sides of the equation, right? On one side, you don't fully understand the actual risk of the vulnerability, and on the other, you don't understand the risk you might be introducing by fixing it. And that's what we hear puts teams in a tough spot, right? That's the feedback we hear. You either upgrade immediately based on severity and risk introducing instability, or you delay the upgrade so you can validate it properly, which slows things down and adds overhead. Now, in practice, neither approach consistently leads to the right outcome because both are operating without the context needed to understand what actually matters. So the issue isn't that teams aren't responding to vulnerabilities, it's that they're forced to make decisions without enough information to make the correct decisions, right? So one of the key pain points, as I mentioned here, is unknown exposure. So one of the biggest challenges we hear teams run into is what we call unknown exposure. At a high level, this just means that teams don't actually know whether a vulnerability is exploitable in their environment. And that really comes down to two things. First, there's a heavy reliance on severity scores without any real application context. And second, there's limited visibility into how dependencies are actually used at runtime. So even if you know a package has a vulnerability, you don't necessarily know if that code is ever executed, whether it's actually reachable, or if it's just sitting there effectively dormant. And the result is teams often can't really distinguish between vulnerabilities that are exploitable and the ones that are purely theoretical. So, because of that, everything looks equally important, which is kind of what we mentioned in terms of the approaches organizations are currently taking, right? They're treating every single one like it's incredibly important to deal with. So, for example, you might see a CVSS 9.8 vulnerability flagged, but the vulnerable code path is never executed. Or a dependency has a known issue, but your application doesn't accept the kind of input needed to trigger it. So in both cases, the vulnerability exists, but it's not actually exploitable. And yet it still gets prioritized the same way. So teams end up spending time on issues that don't actually pose real risk. And without that context, everything can start to look urgent, even if it isn't really needed to be dealt with immediately. Now, another key pain point here is regression. So this is the second major pain point. We often hear about it. Now, this happens when vulnerabilities are flagged as high or critical. The default response is usually to upgrade as quickly as possible. But dependency upgrades aren't always straightforward. Sometimes they require code changes. And even when they don't, there's still a lot of interactions happening between direct and transitive dependencies. So you're not just changing one component, you're potentially affecting an entire chain. And that's where things start to get unpredictable, right? You might pass all your tests, everything looks good in staging, but once it hits production, behavior can start to shift, right? And those changes aren't always obvious. They show up in things like serialization differences, retry logic behaving differently, or subtle changes in how data flows between systems. So the application is still running, but not quite in the way you expect. And over time, that can lead to instability and more time spent on testing and troubleshooting. So, what we often see happens is teams introduce real immediate risk through upgrades while trying to fix vulnerabilities that may not even be exploitable in the first place. Now, this brings us to another key pain point, which is delayed delivery. So, the third major impact, as I mentioned, is delayed delivery. And this tends to happen when teams feel pressure to act immediately on every alert. Developers often have to stop what they're doing, investigate the issue, and figure out how to respond. And even if it turns out to be low risk, that time is already gone. Um, and if an upgrade is needed, the overhead can start to grow pretty quickly. Now you're looking at validation, testing, and coordination across teams. So what starts as a single alert can easily turn into a multi-day effort. And the result is often reduced engineering velocity, right? Future work gets paused, priorities shift, and customer facing releases can start to get delayed. So teams can end up spending more time on remediation than on actually building new features. Now, over time, that can create real friction in the development process. And like the other issues we've talked about, it all comes back to the same root cause, which is we often see teams reacting to vulnerabilities without really knowing whether they actually require action. Now, with all of that said, I'd like to introduce the new vulnerability management in ProGet 26. So let's shift from problem to solution. If you're already using ProGet, you're probably familiar, as per the polls, with things like vulnerability scanning, policies, and enforcement. What we're doing in ProGet 26 is building on that by adding context to how vulnerabilities are actually evaluated. So instead of relying on CVSS alone, ProGet now looks at vulnerabilities in the context of your environment, which means that you can start to understand what actually matters in your system and what you should do about it. And this approach is achieved by what we call PVRS, the Package Vulnerability Rating Scale, which is designed to address these three core problems I mentioned previously. So first, it helps identify which vulnerabilities are actually risky for you in your context, not another company's, your context. Second, it reduces noise from the ones that aren't. And third, it standardizes how teams should respond. We're going to walk through each of those next. So the first thing ProGet will now support is standardizing how teams respond to vulnerabilities, right? Instead of relying on someone to interpret a severity score, the system determines what action is actually required based on real risk in your environment. Again, I can't stress this enough. That is on your environment, not some other companies. So teams aren't left guessing as much. They don't have to decide, is this urgent or what should we do with it? The response becomes more consistent and it's provided in ProGet by ProGet. So in ProGet 26, this is handled through a few pieces working together. You have PVRS categories, which I'll show you in the demo in just a minute, from 1 to 5, which define when something needs attention. You have assessment types, which define what action to take. And then you have risk profiles, which provide the context behind those decisions. So instead of decisions being driven by a generic severity score, they're based on a combination of context, actual risk, and a clearly defined response. So now let's get into PVRS categories. So these define when a vulnerability actually needs to be addressed. So instead of relying on labels like high or critical, ProGet automatically evaluates the vulnerability and assigns it a category from 1 to 5. Now, at a high level, it looks like this. A category 1, no action is needed, it's not really exploitable, and the risk of fixing it actually outweighs the impact. So again, that's how you avoid unnecessary work. Category 2 is low risk. It's something you can plan to address in a future major release. Category 3 is a moderate risk. This is where you'd schedule remediation in an upcoming maintenance cycle. Category 4 is high risk. This needs to be prioritized and fast-tracked into the next maintenance release. And category 5, it's a critical risk. This is where you need to step outside the normal release cycle and remediate it immediately. Obviously, those are exceedingly rare, but so important to know when those do come up. Now, everything in between reflects increasing urgency based on real world risk to your environment. So what PVRS categories really give you is a clear signal of priority based on how urgent something actually is in your system, not just how severe it looks on paper. Now, we'll discuss assessment types. So if categories like the 1 through 5 we just discussed tell you when to act, assessment types guide you on how to respond. Each category maps to a specific response. So categories 1 and 2 map to monitor. So in these cases, there's no immediate action required. The risk is low or not really exploitable, and it can be handled over time through normal dependency updates. Category 3 maps to remediate, which is to say, here there is a real risk, but it's not urgent. So you plan and schedule a fix as part of your normal development cycle. And then finally, we have categories 4 and 5, which map to contain, right? So we talk about containment strategy. This is where the risk is more significant and immediate. So action is required right away, whether that's blocking builds, alerting teams, or investigating potential exposure in production. So instead of looking at a severity score and deciding what to do with it each time, the response is already defined. And that helps create consistency across teams and removes a lot of the ambiguity around how vulnerabilities should be handled. Now we'll talk about risk profiles. So risk profiles are what provide the context behind a lot of these decisions. This is where you define what your application environment actually looks like with things such as whether the application is internally facing or externally exposed, what kind of data it handles, and what the impact would be if something goes wrong. And that context is then combined with factors like reachability and exposure to determine the final category. So instead of treating every vulnerability the same way, risk is actually evaluated based on your environment and how your application is using that vulnerable dependency in practice. So the second thing ProGet 26 will do is help truly risky vulnerabilities stand out. So instead of everything looking critical by default, vulnerabilities are evaluated based on how your system actually behaves. And what that means in practice is the ones that are externally exposed, reachable, and genuinely impactful naturally rise to the top. This is driven by a few key pieces working together. First, you have your risk profile, which defines your application environment. Then you have your PVRS categories, which reflect real world risk for you. And you have notifiers, which make sure high risk vulnerabilities actually get surfaced to the right teams. So the end result is pretty simple. The right issue gets visibility and urgency, but based on actual risk, not just severity labels. Now, the third thing ProGet 2026's new functionality is going to do is suppress distracting alerts about unexploitable vulnerabilities, right? So this is going to help further reduce noise because a lot of vulnerabilities are technically valid, but they're not actually exploitable in your system. So getting notified about them just creates noise. So ProGet identifies these cases and treats them as low priority, which means they don't interrupt day-to-day development. And in ProGet, this is handled by suppressing low-risk vulnerability alerts in tools like NPM Audit and NuGet Audit. So now we're going to jump from my slide deck here to the live demo of ProGet 26. And this functionality is so hot off the presses. I actually have a little bit of a script printed out here, a little old school with the printed out version. So I'm going to be going through that just to make sure I show you everything because this is, like I said, hot off the presses. So we're going to show you how these features work in ProGet 2026, which will be available. Like I said, we're aiming for something like next week, and you can update as soon as your interest or your organization allows. So first, let's start looking at how vulnerability now appear in 2026. So for this demo, we're going to look specifically at a package, a NuGet package called .NET Zip version 1.15, which is a vulnerable package that we currently have in one of our feeds. And that feed is named RM NuGet approved. I assume y'all already, as most of you ProGet users, are familiar with package promotion and the concept of unapproved and approved feeds. So we're going to go into RM NuGet approved, and we're going to scroll down to .NET Zip version 1.15. We're going to head over to that vulnerability. Now, we head over to this vulnerability. We're clicking on the vulnerability tab in this package. Obviously, you're already familiar with some of this from your current use of ProGet. Now, we'll head over to the vulnerability tab, and we will see the details of this vulnerability. So this is obviously going to be new here. You're going to see these categories in the assessment. So in this case, .NET Zip is categorized as a level 4, and the assessment made is to contain it. So we need to contain .NET Zip because it is a category 4. So why is this the case? It's because this particular package version has a directory traversal vulnerability, which ProGet has detected. We can see here, like I said, that it shows in the vulnerability tab. It shows the PVRS category, which tells us when it needs to be addressed, indicating the category 4, and in assessment types, which tells us what we should do, which again, containment strategy. So for example, like I said, category 4, which means it needs to be remediated in the next release. And we can see, as I've mentioned, it is assessed as contain. So the expected response is to investigate the impact of this vulnerability on production and notify our team that this vulnerability was identified. Now, while we're applying those fixes, ProGet will prevent this dependency from being used in any builds. So instead of seeing some arbitrary high or critical label, we immediately understand both the urgency for response contain. So now that we've seen how vulnerabilities show up in 26, let's look exactly how ProGet determines these categories and assessment types. So I'm going to show you next is the risk profiles. Let's make sure I click on the right one, package policies and rules. Yeah, okay. So I'd like to show you how they exist in ProGet. These define the organization's environment and are configured in ProGet's policy settings. So we're going to head over here. So by default, ProGet includes a baseline risk profile that assumes your organization isn't dedicating significant resources to vulnerability management. These defaults assume that your organization's network is inaccessible from the public internet, right here. Your access interface is a web browser. Service outages, data breaches, and data tampering are considered unacceptable to your organization. So you can see we have these 5 settings. These are internally set. You can click on edit and you can change those. I'll show you that in just a moment. So in ProGet, service outages, data breaches, and tampering are configured at one of 3 levels. Like I said, I can show you that. Click here on impact. You can see there's disruptive, unacceptable, and tolerable. So essentially, the system starts from a conservative but practical baseline that works for most typical environments. The risk profile we are looking at here applies globally in our instance and will by default apply to all feeds and feed groups. However, as ProGet users, I'm sure you know that, but like other policies in ProGet, risk profiles can be scoped to specific groups or feeds. So what I'd like to show you now is another risk profile that has been configured for a specific feed, and that specific feed is named st-nougat approved. So clicking back, and that is st-nougat approved. I'm going to click here and edit and show you what this one looks like. So here we can see another risk profile that we've already configured to be different to that of our global settings. So for this risk profile, we've adjusted our service outage, data breach, and data tampering risk levels from unacceptable to disruptive. So you can see that was done here. Click on this, right? Impact. These were changed to disruptive here. And that's what we have for our custom scoped feed st-nougat, right? So the reason we have configured them as such is that while these 3 risk factors would result in negative outcomes, the systems and data involved are not deemed business critical, do not involve highly sensitive information, and have sufficient recovery measures in place to risk the overall impact. So now that we've seen how this risk profile has been configured independent of our global policy, we're going to see how this impacts the category and assessment type for the same .NET Zip vulnerable package we looked at earlier, but instead we're going to show it in the st-nougat approved feed, and that is down here. So we're now going to click into that, and I'm going to click on the vulnerability tab, and you can see that with the service outage, data breach, and data tampering all set to disruptive instead of unacceptable, the same vulnerability is down here at a category 2 and is assessed as monitor. So the expectation here is that we would plan remediation, but without the same sense of urgency had it been categorized as a 4. So before these fixes are applied, this package will still be usable in builds as the vulnerability hasn't been assessed as contained. So again, we don't see some arbitrary label. We instead understand both the urgency and response. So as we saw earlier from the global risk profile, ProGet comes configured with a baseline risk profile set up out of the box. I'm going to go back to it right here, right? We have the baseline risk profile set up out of the box by default. However, these should be configured to reflect your own organization's environment. So we're going to show you live how changing some of this can be done and what happens when you start making changes. So we've headed back to the global risk profile. I'm going to show you how to do this. So in this demo, let's say the organization environment service outages have a lower operational impact due to some established workarounds. So we can change service outages to tolerable. From disruptive to tolerable, We're going to make that change. That has, obviously, you can see right here, it is tolerable while these are still unacceptable. I'm going to go back to NuGet RM unapproved, which is the feed that reflects the global policy. I'm going to click on .NET zip again. I'm going to go to vulnerabilities. Now remember, it was a 4 and a contain before. You can see it has now been lowered to 3. Since in this particular environment, service outages are considered tolerable due to lower business impact, reducing the overall risk associated with the vulnerability. Now, let's quickly go back to our global risk profile yet again, and we are going to make further changes to it, right? Let's say that for whatever reason, data breaches are also not unacceptable, but are in fact tolerable. There's, let's just say, a reason behind that, such as, the organization has some workarounds or things to that effect. So we're going to change that. And vulnerabilities, you can see it has now been reduced to a level 1. So that has, obviously, in this context, the vulnerability is considered significantly less risky and can be handled through normal monitoring workflows, which is what a number 1 means. So, and that's really the key point here, right? The vulnerability hasn't changed at all. What's changing is the environment it's being evaluated in. Now, you may have noticed that through this whole time, the assessment has remained as contain. Now, ProGet will automatically reassess the assessment type the next time the vulnerability database is downloaded, which, if your server is connected to the internet, that would be every night. But let's just say we can also manually reassess. So I'm going to click into here, into the admin. I'm going to go to vulnerability assessment types. I'm going to click into vulnerability assessment types. I'm going to reassess all vulnerabilities. Again, this is a manual move. It would be done automatically every evening. Now I'm going to go back to RM NuGet approved. I'm going to click on .NET zip. I'm going to click on vulnerabilities. And you can see that it has now been changed to monitor. So we've made all of these changes to the global risk profile. But what about the other feed we looked at earlier with its own scoped risk profile? As it adheres to its own risk profile, the changes we just made to global, rendering that vulnerability a level 1 and to monitor, we're going to go back to the feed that is governed by this custom policy, and we're going to click back to here, not making any changes whatsoever. This is still a category 2, and it's still a monitor, exactly as we showed it earlier in this demo. So this shows us that we can scope different risk profiles to different applications in our organization. Vulnerabilities may pose real world risk in some of our environments, but not in others, and controlling this distinction is important. This is also a good time to point out that these assessments are not fixed and can be manually overridden. So, for example, while this is set to monitor, we can override it to remediate. A reason for doing this may be if we determine that this particular application is used in a way that increases its exposure or handles more sensitive data than initially assumed. So I'm going to click here, and I'm going to override and change it to remediate. That is what we want to do here. Boom. So now you'll notice there is this small star icon on the assessment type. This indicates that it has been manually overridden. This makes it much easier to distinguish assessment types determined by ProGet from those that have been manually overridden. So next, I'd like to talk about customizing assessment types in ProGet 26. As we have established so far, ProGet maps PVRS categories into 3 assessment types: monitor, remediate, and contain. So I'm going to click down to here. But this mapping is not fixed and can be manually customized based on the needs of our organization. So let's head over to our assessment types and see how that's done. So from this page, we can change which categories map to each assessment types. This way we can adjust how strictly each response applies to our workflow. So, for example, if I wanted to still be warned about smaller risks like category 2 vulnerabilities so they don't get overlooked, I could set category 2 to also map to remediate the assessment type. So I will do that now, right? So I now want 2 to join 3 in the remediate section. So what I'm going to do is I'm going to set a custom rule. I want it to apply to PVRS categories. I want it to be 2 and 3. And now we have 2 and 3 over here. Now, obviously, what I have to do from here is I can't have these contradict. So I'm going to yet again create a custom rule. I'm going to apply it to PVRS categories. And I'm going to remove the 2, or just by virtue of that, recreate this. So now you can see I have category 1 is monitor, remediate is 2 and 3, and contain is 4 and 5. So that is something very easy to do. So I'll be able to do that accordingly. So now we've customized the settings so that category 1 vulnerabilities will be assessed as monitor, while 2 and 3 will be assessed as remediate. Category 4 and 5 will still be assessed as contain. Now, we've looked at customizing our existing assessment types, but ProGet also allows you to create your own. So let's just say you're in a situation where you have a team that might choose to have a human, right, a person, review severe vulnerabilities, then decide on how to respond. Here, they may want anything labeled contain to be reviewed first by their project lead, rather than the vulnerability being automatically assessed as contain to avoid triggering build failures. So what we will do is create a new review assessment type that will apply to any category 4 or 5 vulnerabilities. First, we will need to prevent vulnerabilities from being automatically assessed as contain. So I'm going to select contain. I'm going to apply a custom rule and do not automatically apply for these ones. So that is set to there, manual only. And now I'm going to create a custom assessment type, and this is going to be called manual review. We'll go with the color custom. We can put that in there. Set custom rule. And we're going to now go in there and select apply to category 4 and 5. So we're going to click this. And then now category 4 and 5 that have been assessed as contain are assessed as manual review, instead creating a clear list of severe vulnerabilities that need to be reviewed by our project lead before being manually assessed. This assessment type can also be set to expire after a certain amount of time. So if no manual assessment is made, the vulnerability becomes assessed. So I can do that, add 20 days. Now it has a expiration of 20 days from now. This will ensure that it gets revisited and doesn't sit indefinitely without being reviewed. So we have that in place. Now, one final thing that I'd like to demonstrate today is how ProGet can reduce vulnerability noise by suppressing distracting alerts from low-level vulnerabilities in your reporting tools, such as NPM audit or NuGet audit. So with ProGet 26, low-risk vulnerabilities, such as those assessed as monitor, can be suppressed by changing the emitted severity level of the assessment type. So I'm going to go to monitor here, and I am going to click on do not emit. Boop, there we go. And so now anything assessed as monitor will not be shown in your reporting tools like NPM audit or NuGet audit. In this case, category 1 vulnerabilities. So this means they won't trigger alerts, they won't interrupt builds, and they won't pull your developers into unnecessary work. So instead of reacting to everything, teams can stay focused on what vulnerabilities actually matter. So that brings us to the end of our demo here. And just as a review, so now that we've seen ProGet 26 in action, let's quickly recap what's happening end to end. So at a high level, ProGet moves vulnerabilities from detection to action using context from your environment. So each vulnerability is evaluated based on how it behaves in your system, then assigned a category and mapped to an assessment type. And that assessment is really what determines how it should be handled. So instead of relying on severity alone, teams are working from system context, defined categories, and consistent assessment types. So what shifts here is that interpretation moves away from the individual developer and into the platform. And that can make a big difference, right? In that it can help reduce the time spent triaging vulnerabilities, and it also helps avoid unnecessary or overly cautious upgrades, which obviously is a return of time to your devs and your ability to maintain or increase release velocity compared to it being slowed down by unnecessary work. So that brings me to the end of our vulnerability management in ProGet 2026 presentation. So thank you, everyone. Looking forward to connecting with all of you later. All right, bye.